Hi there, boys and girls, and welcome back to Conquering Math, where it all adds up. Today we will have an introduction to integers. Let's dive on in. By the end of today's lesson, you will be able to use positive and negative integers to solve real-world problems and identify the opposite of any integer. There are several Common Core state standards today: 6 NSC 5, 6 NSC 6b, and 6 NSC 6c. Before we discuss integers, let's take a look at what a whole number is. A whole number is a positive number, or zero, with no fraction or decimal part. For example, 0, 1, 2, 3 are all whole numbers. So are 99 and 100. The list continues on. Now let's talk about an integer. An integer is a positive or negative number, or zero, with no fraction or decimal part. So some examples are negative 3, negative 2, negative 1, 0, 1, 2, and 3. Positive numbers are any number that is greater than 0. This does include fractions and decimals. Here are some examples: 1, 100, 1/4, and 29.55, or 29 and 55 hundredths. Negative numbers are any number that is less than 0, and this includes fractions and decimals. Here are some examples: negative 1, negative 100, negative 1/4, and negative 29.55. We also need to know what opposites are. Two numbers are opposites if they are the same distance from 0, but one number is positive and the other is negative. For example, negative 5 and 5 are opposites because they are both 5 units away from 0. Let's take a look at how to represent integers on a number line. When drawing a horizontal number line, positive numbers measure distances to the right of 0, and negative numbers measure distances to the left of 0. Start by drawing your number line. This time we'll place 0 in the middle, and to the right we have positive 1, positive 2, and positive 3. To the left we have negative 1, negative 2, and negative 3. When drawing a vertical number line, positive numbers measure distances above 0, and negative numbers measure distances below 0. We can draw our number line. Again, we'll place 0 in the middle, and this time we have negative 1, negative 2, and negative 3 below 0, and positive 1, positive 2, and positive 3 above 0. Let's also take a look at opposites. 2 and negative 2 are opposites because they are both 2 units away from 0 on the number line. Now we're ready to take a look at our first example. Use a positive or negative integer to represent the situation. A student withdraws $5 from his lunch account to buy lunch. Withdrawing reduces the money in your account. In this case, we need to use a negative integer. So negative 5 represents the change to the student's lunch account. For part B, Stefan gains 230 erasers in his collection. Gains indicates a positive number because he has more erasers than he used to have. In this case, we could use the positive integer 230 erasers. For example number 2, we will be graphing integers on a number line. Part A. Graph the following integers on a number line: 2, 4, negative 1, and negative 2. We'll start by drawing a number line, and we'll go from negative 4 on the left to 4 on the right. Start by placing 2 spaces to the right of 0. Then you can graph 4 spaces to the right of 0. Negative 1 will be 1 space to the left of 0, and negative 2 will be 2 spaces to the left of 0. Now for part B. Graph the integer and its opposite. Remember that opposites are two integers that are the same distance from 0, but one is positive and one is negative. We'll start by drawing our number line, and we'll graph 3 spaces to the right of 0. 3's opposite is negative 3, so now we need to go 3 spaces to the left of 0. Example number 3 will be a real-world example. Use integers and a number line to model and solve the following problem. A football team starts on their own 20-yard line. On first down, they lose 10 yards. On second down, they gain 30 yards. For part A, we will need to write an integer to represent the football team's change in position at each point in time. We'll have time on the left and integer on the right. At the start, the football team is on the 20-yard line. After first down, the football team lost 10 yards, so our integer will be -10. On second down, the team gained 30 yards, so our integer should be 30 or +30. Now let's look at part B. Model the team's movement on a number line. Use an integer to show the team's progress on each play. We'll start by drawing our number line, and keep in mind that in football the 0-yard line is at the end zone. That's why we have 0 drawn at the end of the number line rather than in the middle this time. Once again, we'll have the time, and this time the location. The football team starts at the 20-yard line. On first down, the football team loses 10 yards. This means they are now at the 10-yard line, because 20 yards minus 10 yards brings them to the 10-yard line. On second down, the team gains 30 yards. This will bring them to the 40-yard line. Today you learned to use positive and negative integers to solve real-world problems and identify the opposite of any integer. There were 3 Common Core state standards today: 6 NSC 5, 6 NSC 6b, and 6 NSC 6c. Now that you are familiar with these techniques, complete the independent practice problems in your guided notes packet. Then watch the independent practice solutions video to check your work. Thanks for watching this episode of Conquering Math, where it all adds up. I'll see you next time.